Hey everyone, and welcome! We're about to dive into some hidden physics, the kind that makes your life easier every single day, probably without you even noticing.
You know that feeling, right? Whether it's a huge project or just something small, it feels like we're always putting in effort, always using up energy. But what if I told you there's this ancient trick, a simple secret to make all that work feel like, well, less work?
I mean, just think about your morning. You turn on a tap, stir your coffee, maybe open a gate. Every single one of those things, no matter how tiny, takes work. But for literally thousands of years, people have been using a clever hack to get way more done with a lot less sweat.
And that hack? It's called a mechanism. You can think of it as a tool that basically gives you a superpower, a way to, amplify your own strength. And no, it's not magic. It's physics. And these simple tools, they're everywhere.
And the hero of our story today, the absolute superstar of the simple mechanism world, is the lever. This is one of the first tools people ever used to move massive objects, and the idea behind it is just brilliantly simple.
Okay, so that's the fancy textbook definition, but really all it means is you've got a rigid arm that turns around a fixed point. That's it, a bar and a pivot. So, how do those two simple things give us so much power? Well, to get that, we've got to learn the lingo.
So, every lever system has three main parts. You've got the fulcrum, that's the pivot point. Then there's the load, that's the heavy object you're trying to move. And finally, the effort. Yep, that's you putting in the force to make it all happen. So say it with me, fulcrum, load, effort. Got it? Awesome. Because how you arrange those three things, that's the secret sauce. All right, now that we've got the vocabulary down, let's get to the really fun part. We're going to pull back the curtain on the lever's magic trick. It's a concept in physics called mechanical advantage. Mechanical advantage, or MA for short, is basically a physics cheat code. Seriously, it's just a number that tells you how much a tool is multiplying your effort. So when you've got mechanical advantage, you can use a tiny bit of force to move a huge, heavy load. So how do you get this awesome power-up? It's all about distance. It's actually super simple. To make things easy, you put the heavy thing, the load, right up close to the fulcrum. Then you apply your force, the effort, as far away from that fulcrum as possible. That extra distance? That's your secret weapon.
Okay, to really nail this down, let's think about the perfect real-world example of a first-class lever, something I bet we've all played on. The seesaw.
All right, scenario one. Picture this. Two friends, they weighed the exact same, and they're sitting on a seesaw. Everything's perfectly balanced. So in this setup, the fulcrum is right in the middle. The effort from one person is totally equal to the load of the other person. And here's the key part. They're both sitting the exact same distance from that pivot in the center. So what does that mean? Well, the mechanical advantage is 1. That means you get out exactly what you put in. Your force isn't multiplied at all. No advantage. It's perfectly fair, I guess, but not very helpful if you're trying to make work easier. Okay, but now for the classic playground problem, right? What happens if you want to lift your friend who's way heavier than you are? Is that even possible? Oh yeah, with physics, it absolutely is. Here's the trick, and it's brilliant. You don't change the people, you change the lever. You tell your heavier friend, the load, to scoot up closer to the middle, closer to the fulcrum. Meanwhile, you, the effort, you sit as far back on your end as you possibly can. And boom, this shows you the power of leverage right there. Just by changing where you sit, your mechanical advantage is now greater than 1. Your small effort gets multiplied, and you can lift that heavy load no problem. You just used physics to beat physics. But what if you get it wrong? Let's flip the whole thing around. What if you, the lighter person, sits super close to the fulcrum and your heavier friend is way out at the very end? Well, in this case, you've just put yourself at a huge disadvantage. The load is way far from the pivot and your effort is right next to it. You're literally making the job as hard for yourself as you possibly can.
The result? Your mechanical advantage is less than 1. That means you'd have to push harder than your friend's actual weight just to lift them. You've created a mechanical disadvantage. You're stuck.
So, look, if there's just one thing you remember from all this, make it this. The closer the fulcrum is to the load, the easier it is to lift. That's the golden rule. Where you put that fulcrum, it's everything. Okay, now that you get the principle, I promise you're going to start seeing this stuff everywhere. That seesaw, it's not just a playground toy. It's a perfect model for hundreds of tools we use every single day. Think about it.
Prying a nail with a claw hammer, the hammer's claw is the fulcrum. Popping open a bottle, the edge of the cap is your fulcrum. Heck, even a pair of scissors is just two first-class levers that are joined together in the middle. Once you see that pattern, effort, fulcrum, load, you'll realize these simple, powerful machines are absolutely all around you.
So there you have it, the fundamental power of leverage. I want you to look around today, in your kitchen, your garage, wherever, and ask yourself, what first-class lever am I using right now? How am I using physics to make my life just a little bit easier? Because once you start looking, you'll see them everywhere. Thanks for joining this explainer.